We're going to continue our exploration into trigonometry by dealing with the law of sines. The law of sines is something that allows us to solve a triangle, which means, again, that we are finding missing side lengths and missing angles. The first case that we would have would be when we're solving a triangle where we know two angles and any side, and that is either side angle angle or angle side angle. In order to identify how to solve this case, we want to first identify what an oblique triangle is. An oblique triangle is a triangle that does not contain a right angle. This means that you could have three acute angles, or you can have one obtuse angle and two acute angles. Whenever you have an oblique triangle, given the length of a side and any other two parts of the triangle, we can solve this. So not just talking about a right triangle, when we have either the three acute angles or one obtuse angle and two acute angles, there's four different cases that we encounter involving angles and sides. For the first two cases, case one is two angles and any side known. That's either angle side angle or side angle angle. Or two sides at an angle opposite one of them are known. This is side side angle. In these two cases, we use the law of sines to solve these triangles. Cases 3 and 4 are we either know all three sides and we need to find the angles, or we have two sides at an angle between them are known. That's side, 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 and side angle side. And for these, we use the law of cosines, which is in the next section. The three triangles you see here, these are three oblique triangles with all three acute angles. The first one is angle side angle because you know angles A and B and C is between them. That's the side length C. In the second triangle, you have side angle angle because you have side C and then angle B and angle C. And then the third case, we have side side angle because we have side B, side C, and then angle B. These triangles can be solved using the law of sines. What is the law of sines? Well, let's first discover the law of sines using the triangle below. For this triangle that we have here, we have angles A, B, and C, side lengths A, B, and C, and notice that the side A is opposite the angle A, side C is opposite the angle C, and side B is opposite the angle B. We have H, which is our altitude. So let's separate this into two separate triangles. Let's consider this triangle here. That's a right triangle where the sine of A is H over B. Now let's look at the smaller triangle that's also a right triangle, and we can say that the sine of B is equal to H over A. Solving for that H value, we see that H is equal to both B sine A and A sine B. And since they're both equal to H, by substitution, we know that B sine A is equal to A sine B. Dividing by sine A on both sides, we have B equals A sine B over sine A. Now dividing sine B on both sides, have B over sine B equals A over sine A. And you can do this for any of the values, which means that B over sine B is equal to A over sine A is equal to C over sine C. And their reciprocals are true as well. So you could have the side lengths in the numerator, or you could have the angle measures in the numerator. And it doesn't matter which combination you have, as long as you have the three cases that we had listed before. It either needs to be angle, side angle, angle, or side angle. You can't have an A, a B, and a C component. You either need two A's and a B, two B's and an A, two B's and a C, two C's and an A, something like that. So the law of sine says that if you have a triangle ABC with side lengths A, B, and C and opposite angles A, B, and C, then either A over sine A equals B over sine B equals C over sine C, or sine A over A equals sine B over B equals sine C over C. This means that the ratio of the length of the side of the triangle to the sine of the angle opposite that side is the same for all three combinations. If we have the measure of an angle A and the lengths of sides A and B for the triangle being given, depending on the length of side A, which is the one that's shown here in purple, relative to the length of the altitude, there's four different scenarios that actually occur. We can either have no triangle, one right triangle, an oblique triangle, or two different triangles, one that's acute and one that's obtuse. If your side length A is shorter than your altitude H, then A is too short to meet side C, and so this is not a triangle. If A is equal to the altitude, then this forms a right triangle, and so you have the one right triangle scenario. When A is longer than B, you only have one oblique triangle that's possible. But if A is in between B and the altitude H, then there are two triangles possible, one acute and one obtuse. This is going to be that A intersects side C at an obtuse angle or at an acute angle. It's not going to be both, but those are the two different possibilities, and you just have to determine which one you have. When you have the law of sines, you can calculate the area of the triangle using a formula other than just area equals 1/2 base times height. That's 1/2 the altitude times the base, which we have labeled C. What if we don't know H? What if we have other angle measurements instead? Recall earlier from the triangle that we had here that the sine of A was equal to H over B, or H was equal to B sine A. Then we could calculate the area by saying the area is equal to 1/2 B sine A times that base of C. And you can use this, you can adjust the different variables and solve the same thing to find there are three different versions of this depending on if you want the sine of A, the sine of B, or the sine of C. So those three formulas are here. For triangle ABC with sides length A, B, and C across from angles A, B, and C respectively as drawn above, the area can be calculated by taking 1/2 BC sine A, or 1/2 AB sine C, or 1/2 AC sine B. So you're using all three letters. One is an angle and the other two are sides. If you use sides B and C, you're taking the sine of angle A. If you use sides A and B, you're taking the sine of angle C. And if you use sides A and C, you're taking the sine of angle B. Head over to the skill practice videos to see solving triangles using the law of sines, applying the law of sines to find heights, to find angles, and doing applications involving real-world scenarios such as there's a plane here, here's the angle of elevation, how far away is it from this point? Types of questions like that.